The solution of an equation in 3 variables, such as 2x plus 3y minus z is equal to 4, is called an order triple. There are 3 of them, and is written as x, y, and z. Now we have 3 solutions should satisfy all 3 equations. The graph of a linear equation with the 3 variables is a plane, not a line anymore. The number of possible solutions are shown here. Here it is. So if you have a single point of intersection, you look like that. If the 3 planes intercept points of a line in common, in this case, points of a line in common, this would be the same case. This would be where all the planes would be right on top of each other. So you have infinitely many solutions. It could happen with the plane as well. This would be a case where all those planes are parallel. There's no point of intersection. It could happen. So, or would be 2 of them on top of each other. The other one would be parallel to that. Still would be no point of intersection for all of them. So this would be where you can picture these planes. So let's take a look at that. The 3 planes may meet at a single common point, as we showed, or you could intersect at a line, or right on top of each other, or all would be parallel, would be no solution. The steps that we're going to show, we're going to use a term, focus variable, that you need to eliminate. So you want to pinpoint a variable to eliminate. It's very important to see which one you want to eliminate. The focus variable will always be present in all the equations, which will be used twice to eliminate this variable. So let's take a look at the example to see what all that means. So there are steps involved. For the example I'm going to show, step number 1, you want to select a variable and equation. A good choice for the variable, which we call it the focus variable, is one that has the coefficient of +1 and -1, just like we did before with 2 equations and 2 unknown. And then select an equation on that contains the focus variable, and then eliminate that. So let's take a look at the next steps. Use the working equation and remaining equation of the original system. The result is another equation, 2 variables. So you end up, by doing that, you end up getting 2 equations and 2 unknown. You go back to what we did earlier and solve that and plug it back into the original equation. And then, of course, you check the answer. So let's take a look at the example. Solve a system of equations. Here we have 3 equations and 3 unknown. Step number 1 was to select the variable. Now, what variable do you want to select to eliminate? Well, let's take a look. We said we're going to look at the one with the coefficient is 1. So we have a lot of choices here. Let's select the variable y as our focus variable. Again, doesn't matter which one. If I select y here and take a look at equation number 1 and 2, I can eliminate that, right? I can easily take the first equation and second equation. They're already opposite of each other. That's why I select this one. I don't have to do anything to this. And by doing that, I create a new equation in terms of the other variables, which is namely x and z. So I eliminate y. Now, I need to eliminate y in another 2 equations, the next 2 equations. So let's do that. So the next step is to pick equation 1 and equation 3. Again, you could pick the first two or last two, or first two and first one and the third one. All works the same way. But make sure you eliminate the same variable. So step number 1 in this case was we pick the first two equation, eliminate y. We call that equation number 4. Now we're going to pick the first equation and the third equation. Now we have to eliminate the same variable, which is y. Okay, by doing that, I have to multiply the top row here by something that would be opposite to 2, which is -2, right? So that's why we multiply the top row here by -2. By doing that, you see the coefficient of y becomes opposite of each other. That's exactly what I wanted to do. Now I get the fifth equation in terms of x and z. Then we'll go back again. See, when I pick the first two equation and eliminate y, I got the equation number 4. And now when I'm picking the first one and the third one, eliminate the same variable, I get another equation. I call it 5. So now I end up with 2 equations and 2 unknown. Equation 4 and 5. Here it is, 4 and 5, which there's no y in there. So now we all should know how to solve this for x and z, right? Just because this is taking us back to solving 2 equations and 2 unknown, right? To do that, now we can use the addition or elimination method again. Since the coefficient of z is already opposite of each other, I don't have to do anything. I just have to add these two and solve for x. 2x minus 3x would be minus 1x. 4 minus 3 would be equal to 1. So x equal to -1. Once I find one of these variables, I substitute it back into either of these 2 equations, 4 and 5. If I put it back to equation 4, I would get x equal to -2. If I substitute for each x -1, you get 2 times -1 would be -2 plus, you have 3z is equal to 4. So if I add that -1 to both sides of the equation, I get 4 plus 2 would be 6 here. So I get 3z is equal to 6, z is equal to 2. So I find z and x that way. Now I know z and x, I can substitute that into either of these 3 equations. I can solve for y. Doesn't matter which one. Okay, we substitute -1, x equal to -1, z is equal to 2 into equation number 1, and we just simply solve for y. We're done. We found x equal to -1, y is equal to 1, z is equal to 2. If I substitute that into all these 3 equations, it would add up to 2, 2, and 1, and it works. This is a solution. Once again, I picked first 2 equations, eliminate the y. First equation and third equation, eliminate the y. Create the 2 equations and 2 unknown. Solve for those 2 variables. Plug it back into equation number 1 to solve for x, y, and z. You can, again, pick the first 2 equations, eliminate 1 variable, or last 2 equations, eliminate the same variable, obtain the same result.